Today, we dive into how nickel catalyst is used to produce margarine via hydrogenation of unsaturated oils in the first part of the picture. In the nickel knee surface provides an active surface where molecules can interact. Hydrogen molecules are adsorbed onto the nickel surface and split into hydrogen atoms. Unsaturated oil molecules with double bonds are also adsorbed onto the nickel surface. Hydrogen atoms move to the oil molecule, breaking the double bond and turning it into a saturated fat. The saturated fat molecules formed are released from the nickel surface, and the nickel is ready for the next cycle. Step 1. Introduction to process. Hydrogen gas H2 is bubbled through vegetable oils in the presence of a metal catalyst, for example nickel. Step 2. Chemical change before unsaturated fats with double bonds C=C. After saturated fats, no double bonds, only single bonds C-C. Refer to chemical diagram in the slide.
Step 3. Physical change before. Liquid oil after. Semi-solid fat, margarine. Refer to texture images. Result. Liquid oil becomes semi-solid at room temperature. Useful for baking, extended shelf life, and food texture. Next, we look at the role of nickel as a catalyst in the hydrogenation process. Nickel is used because it provides a solid surface on which the reaction can take place. On this nickel surface, hydrogen gas will first stick. This process is called adsorption. H will break down into hydrogen atoms. At the same time, unsaturated oil molecules will also stick to the same surface. The hydrogen atoms from the H will move to the oil molecule. And this will break the carbon-carbon double bond, C=C, that is present in the unsaturated oil. When this double bond is broken down, the oil becomes a saturated fat, margarine. Interestingly, this nickel does not change at all, it does not enter the product, and can be recycled for further processing. That is why nickel is very useful and efficient in the food industry, especially for producing stable and easy-to-spread margarine. Let's look at the types of reactors used in this hydrogenation process. In industry, this process usually occurs in two types of reactors, fixed bed reactor and slurry reactor. For a fixed bed reactor, nickel as a catalyst is arranged in solid form in a long container. Oil and hydrogen gas will flow through this reactor, and the reaction occurs when they come into contact with the static catalyst. Meanwhile, in a slurry reactor, nickel is stirred with oil in the form of a fine powder. So, all the ingredients are mixed and saturated in one tank. Hydrogen will be added to this system, and the reaction occurs when everything is mixed evenly. Both types of reactors have their own advantages and will be chosen depending on the scale and needs of the industry. Fixed bed is like a fixed path, oil and gas just pass over the catalyst. Slurry is all mixed in one tank, more flexible but difficult to separate the nickel. Now let's compare the advantages and disadvantages of the two types of reactors. Slurry reactor and fixed bed reactor. The main advantage of slurry reactor is its excellent heat transfer. This is important because the hydrogenation reaction is exothermic, so excess heat can be controlled more efficiently. However, the disadvantage is that we need to separate the nickel from the mixture after the reaction. This filtration process can be challenging and takes extra time. Fixed bed reactors are also easier to manage. Because the nickel catalyst remains in place, we do not need to refilter it. Nickel catalyst plays a vital role in the hydrogenation of oils, transforming unsaturated fats into solid, shelf-stable margarine efficiently. Its reusability, surface activity, and compatibility with industrial reactors make it essential in food processing industries.